This is a circular motion question, but it's a vertical circle, so I might put that somewhere. Vertical circular motion. The question is, so you're going around this circle here. It says, what's the minimum speed that the car can have at position A if it's not to leave the rails and start to fall? Okay, for its minimum speed, for this thing here, minimum speed that doesn't fall or that you're weightless, the same question is that the centripetal acceleration equals gravity. And the formula for centripetal acceleration is v squared on r. That equals gravity. So we've just got to rearrange to find v. So in this case we've got v squared equals rg, v equals square root of rg equals the square root of radius 15, 15 times 10 equals the square root of 150, that equals 12.2 meters a second. 12.2 meters a second. Next question. Alright, that's the same diagram with the radius there. Mary, his mass is 60, she's a passenger in the car. What will Mary's apparent weight be at position A when travelling at this speed? Explain your answer. It turns out her apparent weight is 0. At the top, the reason why this, at the top, the only force on her when she's at the minimum speed is gravity. And because there's no normal force, therefore because no normal force, her apparent weight is 0. So let's just go back over that again. When she's at the top, she's in this car here, her total force is towards the middle. This is centripetal acceleration. The minimum speed she can go is when, so that the cart doesn't fall off, is that the actual forces is only gravity. Okay, so that equals downwards force of gravity. Force of gravity. And there's no normal force there. So normal force is 0 and normal force is your apparent weight. Alright, she's now past this point B at the bottom of the circle, and the cart has a speed of 5.5, so that's the radius here, and Melanie's mass from the last question was 60 kgs. So what's Melanie's weight at the point down the bottom B? I'll show you working. The first thing we've got to do is work out the total force on her. Now in a circle it's always mv squared over r. So total force is 60, that's her mass, velocity is 5.5 squared, and the radius is, what's the radius, 15. You do that calculation, you get 121 newtons. So that's a total force. 121 newtons, and if she's at the bottom here, B, that's towards the centre. That's made up of her actual forces, which are 121 newtons up, which are her gravity force, and that equals, she's got 60 kg, so 600 newtons down, plus some other force, which is the normal force, because these two have to give 121 upwards. So if you've got 600 down plus something up, what is that something such that it equals 121 up? Well, it must be bigger than gravity, because it's got to cancel out gravity and leave over 121, so it must be 721 newtons up. 721 up, 600 down, give a total of 121 up. So that's the normal force on her, and that normal force is apparent weight. Normal force equals apparent weight.